I want to give a physical interpretation of what it means to integrate a function of two variables over a region in the plane. So let's say that we want to compute the integral over a region R of f of xy dA. What might this mean physically? How can we give this a physical interpretation? Well, you can think of the region R as being a physical object, like a metal plate, and maybe the density of the object changes from location to location, the planar density. And suppose we want to compute the mass of the entire metal plate. We're given the density at each point in the plate, and we want to compute the mass of the entire plate. How can we do that? Well, the way that we're going to do that is, as usual, chop up our region R into tiny pieces like this. We're going to chop up R into tiny pieces, and then we're going to compute the mass of each of these tiny pieces. So let's compute the mass of this little tiny piece of our metal plate. And the way we're going to do that is we're going to choose a point arbitrarily inside this little piece. And let's say the coordinates of this point are xi comma yi. How do we get the mass of this little piece? Well, what we do is we take the density at this location, the density, and then we multiply it by the area of this little piece. So f of xi comma yi is what we call the planar density at this point. We're multiplying the planar density by the area of this tiny little piece of our metal plate, and that gives us the mass of our tiny little piece of the plate, at least to a good approximation. And then we just sum up the masses of all the little pieces, and that gives us the total mass of our metal plate, at least to a good approximation. Sum up the masses of all the individual pieces, and we get the total mass of the metal plate. So this gives us a physical interpretation of this integral. If f tells us the planar density of an object at each point in space, then this integral is the total mass of the object. This is the mass of our object.